So hello, everyone. My name is Adam. We're going to be talking about combustible dust today. I've prepared a presentation that kind of covers a little bit of everything related to combustible dust. I'm going to go over what we're going to discuss in a little bit. A little bit of a delay on my slides. So this is what I look like, everyone. I'm one of the engineering managers here at Conversion Technology. As Blair said, we're an environmental and safety consulting firm based outside of Atlanta. We've been going hard at business since 1986. We do safety and environmental consulting for manufacturing facilities across the spectrum of sectors. So I spend a lot of time in the timber industry, and for combustible dust, I'm doing a lot of food and metal fabrication facilities currently. I have a lot of upcoming plastics and rubbers facilities, I think next month. So I'm kind of looking forward to that, to kind of change up from the standard feed mill or food facility. At CTI, we do the gambit of EHS, everything from air permits, stormwater, hazardous waste management, safety. I did run our safety compliance department for several years, and then I kind of fell into the combustible dust full time. It was kind of always part of my repertoire. Just with some of the deadlines coming up, it is all of me at this moment. So what we're going to discuss, I will go over an overview of combustible dust, what it is, some key definitions. I'll then lead in to OSHA's Combustible Dust National Emphasis Program, as well as some of the changes they've recently made to their technical manual, kind of what that means for you, relate it to the NFPA 652 standard, which I'll obviously explain more later. And then the two big deadlines, one that recently just passed, the September 7th, 2020 deadline, and then the upcoming January 1st, 2022 deadline to have DHAs conducted, depending on which industry sector you're on. And then I will lead into a little overview of all the steps to do a combustible dust hazard analysis, a DHA. I will explain my method, CTI's method, what the standard regulates, as well as maybe some of the gray areas that you can maneuver in to make it a little bit more specific for what you have at your facility. And again, if there's any questions, please post them in the chat box. I can see the chat. I will do my best to answer them as I go. If not, we'll have that time. And for anyone that wants a copy of this presentation, my contact info is at the end of the presentation. But if you put your name and email, we're going to email out a PDF of these slides. Hopefully you can use it as a resource. So with all that, a quick definition of combustible dust. Hopefully most of you are not super new to the term, but combustible dust is defined as any combustible solid material composed of distinct particles or pieces, regardless of shape or size or chemical composition, that those particles present a fire or deflagration/explosion hazard when suspended in the air. That's quite a mouthful for a definition, but my examples, I posted some sawdust on a floor, flour coming out of a sifter, metal shavings. You'll hear me emphasize aluminum a lot today. That's just something I was just working on. So those are some examples of basically combustible particulate solids is what we'll be discussing. So some other definitions, you're going to hear me say these words a lot. Fire, deflagration, and explosion. I don't think I need to explain too much of what a fire is, but I do have the definition up on the slide. A deflagration is kind of one of those terms that gets used, but maybe not a lot of people know about. So that is defined in the NFPA standards. I pulled from NFPA 654. Deflagration is defined as a propagation of combustion zone at a velocity that is less than the speed of sound in the unreacted medium. That is not a very, what I would consider the most articulated definition, but a deflagration can be considered like an explosion without the rupturing of equipment. There still could be some potential flame fronts, but I will go into a lot more depth of deflagrations today. I can hear somebody is not muted. But an explosion, I think we all know. But the key for a deflagration is that is what a lot of the standards are written based on. You'll hear fire, fireball, flame front, deflagration. So a deflagration is the occurrence of four specific things. A small combustible particles are present. So let's use flour. Flour is going through a dust collector. When those air pulses hit the bags, you do have small combustible particles that are present. The particles are suspended in the air at a sufficient quantity or concentration. Each dust or particulate has what's known as the MEC, or minimum explosive concentration. That's the concentration that's needed in a given volume for that to be the potential for a deflagration to occur. You need the availability of oxygen as well as an ignition source. Basically, the fire triangle turns into the explosion pentagon, which I'll go over in a couple slides. So with all four of those occurrences present, you do have the potential for a deflagration hazard. One thing to think about, and I just want to kind of make this a little clear, is I am not only looking at inside of equipment. One thing that I particularly emphasize during a DHA that I'm conducting is I like to look at housekeeping, because I think that's one of the hidden dangers of combustible dust. I think a lot of the incidences that have occurred that some of you might have heard about, I think you'd be surprised how many of those were due to poor housekeeping, or what I call dust accumulation. So if rooms or pieces of equipment have the potential for dust concentrations to reach that MEC, minimum explosive concentration, then a deflagration hazard can exist. So I'll go into more of this down the road, but if you're looking at the rafters above your process area, but you sweep the floors 3 times a day, but you don't get up top very often, you could potentially have a dust cloud in that room should that dust fall off the rafters, rain down the ground. And I'll go more into that. So deflagrations, the big thing with that is they generate a great deal of pressure. So when a deflagration occurs in an enclosed area or piece of equipment, that's what the explosion becomes. So we'll consider an explosion as the bursting or rupture of an enclosure or container due to development of internal pressure from a deflagration. So if a deflagration occurs in a bucket elevator, but that bucket elevator is equipped with appropriate deflagration relief panels, or explosion panels, or rupture panels, however you want to refer to them, is if all those deflagration panels blow and it vents out, but the bucket elevator itself stays intact, then you can say that a deflagration occurred, but it didn't explode, didn't blow up the whole casing. And that's actually a case study I'm working on currently, so I can answer more questions of that. So between deflagration and explosion is pretty much a cause and effect. A deflagration occurs, causes an explosion. So with that, as I mentioned, there's the explosion pentagon, very similar to the fire triangle, just obviously a little extra nodes there. So for an explosion to occur, you have oxygen, fuel, ignition source. That is the fire triangle. So you basically have a heat source or flame source mixed with a dispersion of dust clouds, or excuse me, a dispersion of dust in a cloud form, and then containment of that dust cloud. So you have a fire with a rich dust cloud that is contained. So that overpressure will occur and explode and blow the equipment. So that is the explosion pentagon. This is kind of to explain some of the stuff I just talked about. Is one of the greatest hazards of combustible dust is what's called the issue of a secondary explosion. So as I said, dust can accumulate on surfaces with the smallest particle size accumulating in hard to reach places. Typically what I find is when I'm doing a DHA, I look up a lot because I find rafters above drop ceilings as hard to reach places, and therefore just don't get cleaned as often. So you could have the potential for dust to accumulate in those hard to reach or hidden areas. And then what can happen is you would have what's called a primary explosion. So whether a tank burst, dust collector blows, a motor pops if it's overheated and blows the motor, and that would cause, let's say, that room to shake or the building to shake a little bit, causing all that dust that had accumulated in the overhead areas to be dispersed through the air, displaced, falling down, and now that flame or heat source from the initial explosion is now in the presence of a dust cloud. So that can spread fire very rapidly through a building and process, blow the roof off a building, which I have seen before, or otherwise just expose employees to flash fire. So when I'm looking at combustible dust issues, you definitely want to look more at, well, what can explode, but also what are the potentials for fire, the spread of fire, equipment malfunctions to cause heat sources that could then potentially cause fire or explosion hazards. So with those definitions, the question I get asked a lot is, yeah, but what do I have to do? Does OSHA care? I can answer right now, yes, OSHA cares very much. So in fact, OSHA has put out what they call the NEP, the National Emphasis Program on Combustible Dust. It's been in place since 2008. Pretty much the Imperial Sugar explosion here in Georgia back 2008 or so had kind of woke a lot of people's eyes open to the potential for combustible dust hazards. And I can use that example if a lot of you know what I'm talking about, what happened. But with that, OSHA does have the National Emphasis Program, which is going to be mainly for the ability for citations and violations, the ability for them to consult with related to combustible dust, inspect, how to do testing. I'll go more into what that means later, but OSHA does not have a specific regulation on combustible dust. So we all know that lockout tagout has very specific regulations. Regulations are laws that if you violate this, you will be cited for 1910, 147, whatever. OSHA does not have that for combustible dust. They rely on that NFPA consensus standard to provide them the guidance as well. They use the National Emphasis Program to conduct what's called like NEP audits. So they would come to inspect based on this NEP and the violations and citations that could arise. I'll give you some very specific examples of what I've seen for that, but that's how they go about it. In February of this year, OSHA did publish a new section of their technical manual, or OTM. Section 4, Chapter 6, gives some pretty decent guidance on combustible dust. It's kind of, it can be used a little bit for personnel training. I think that would make a pretty good resource for everyone here. So as I said with OSHA, the NEP established guidelines for inspectors. Part of that NEP is it identified industry classes that OSHA should look out for or otherwise inspect. Some of those include food and agricultural products, wood, furniture products, or timber processing, pellet mills, salt mills, all those. Chemicals, which is quite a vague term for chemical manufacturing, rubber and plastics, metal refining, pharmaceuticals, textiles, auto and aviation parts, even recycling facilities and scrap yards due to the metal dust. The one thing to look at for everyone here, I definitely recommend going into OSHA's NEP, as it does provide a list based on SIC and NAICS codes of which industries they have determined have a history of combustible dust incidents or have the potential for one. As Blair said, I do a lot of other stuff. I'm working with OSHA on their robot safety training for their inspectors, and I can tell you right now that kind of depending on who you talk to, you might get a different answer. So I definitely recommend doing the research on your own. Is your facility's SIC or NAICS code listed? And one important thing that even if your facility, your specific sector's SIC or NAICS code is not listed, Inspectors can still come on site to inspect for combustible dust. You can still have combustible dust. You can still have all the hazards that go along with it. In a little bit, when I talk more on some other topics, I'll explain kind of how to determine where you fall into that. So some of the things that I've seen, the NEP identifies several applicable standards for an inspector to cite combustible dust based on. So I have seen the housekeeping, 29 CFR 1910-22, probably cited one of the most as their reason for violation. As I mentioned, the standard specifies housekeeping. I look at housekeeping from a hazard standpoint, as there's plenty, if you don't clean the dust off a motor, that motor can become insulated, overheat, and now you have a fire hazard. So things like that. They'll look at housekeeping frequencies, what's used, how is housekeeping done, which I'll go over some examples more. PPE, kind of, sort of, I see that more really for the dissipation of static, for like grounding straps or FR clothing for maintenance personnel. Hazardous locations, and that's going to be a lot of electrical, a lot of 1910-307, 1910-333. A lot of the electrical gets cited. As electrical is one of the bigger of the frequency of issues that come to pose potential ignition sources. Hazard communication, powered industrial trucks basically are using a rated truck in a rated area, or using a standard forklift to go into a rated hazardous location, rated for combustible dust potential. And then obviously there's industry specific standards that grain handling facilities and bakeries have for OSHA. And then of course, everyone's favorite is the general duty clause. So the thing with the general duty clause is it basically says the employer shall maintain a workplace free of recognized hazards. For those of you that have been on a few of the sides of an OSHA inspection, you know that you can maneuver with the general duty clause, but so can OSHA. So if OSHA shows up and they say you have all this dust, well, that's a hazard, and they can list any number of ways that's a hazard, but it's up to you. You get the burden of proof to prove no, it's not. And I can tell you some examples later on that I've personally dealt with. So when they pull out the general duty clause, as opposed to the previous set of violations I explained, is if there's an issue with a dust collector, for instance, if it's located inside of a facility and it's not properly protected, if you use that dust collector and then return the air back into the facility, which I see in a lot. I know a lot of you in Ohio, you might do that during winter to save on heating costs. Well, that can be done, but NFPA has a very specific requirement for that to happen. And for those of you that know, it's NFPA 652 9.3.4.3.3. I know that was really fast, but I get asked that probably the most out of anything is about returning air. Otherwise, there's ductwork problems, explosion venting that might not be sized properly, or if you have a explosion relief panel on a dust collector and that relief panel, if it blows, it goes right into the front door of the break room, well, they can say, well, that's a potential hazard, and that's kind of where they'll get you. But specifically, the NEP uses the general duty clause to issue citations for primarily going to be the deflagration or explosion or fire hazards within dust collection systems, other containers like mixers, bins, silos, things like that. So I mentioned NFPA. NFPA is the National Fire Protection Association. They are the ones writing these national consensus standards related to combustible dust. A lot of you know NFPA 70E for the electric codes, the building safety codes, 101. So NFPA they're the ones writing these standards. Some of us at CTI were on the committees for these standards. I can tell you right now, those are pretty interesting meetings if you ever get an opportunity to sit in on them. But they can be pretty in depth. Some of the specific combustible dust standards from NFPA. So you have NFPA 652, which is the fundamentals of combustible dust, that is the overarching standard that applies to all facilities with combustible dust. That is where you will find that deadline I had mentioned of September 7th, 2020, which is passed, for all facilities to conduct DHAs. Now that gets superseded for those of you that might be in agricultural and food processing, where NFPA 61 is what's called a commodity specific standard. So NFPA 61 is the prevention of combustible dust issues in agricultural and food processing. For those of you that deal with feed or flour, sugar, food plants, whatever that is, your deadline is going to be September 1st, 2022 for conducting the DHA. I will get more in depth of what that means in my DHA section of the slides. But you do have commodity specific standards for wood processing and timber facilities, NFPA 664. For those of you that might deal with metal fabrication, grinding, even depending on what it is, some of the paint booths, aluminum, things like that, that's gonna be 484, which is the standard for combustible metals. And then if you are installing explosion protection, for instance, you would then fall into NFPA 68 and 69, which is the standards for explosion protection by venting, and then the standards on explosion prevention systems. So the 68 and 69, you'll kind of understand a little bit more when I show you some examples of those. But if you're looking at this slide and you're like, well, how am I gonna, first off, buy all these standards, read all these standards, and understand them enough to kind of know where to go? Well, there's a nice little path that I can explain. It is, you want to start with NFPA 652, as that is the overarching standard. So you want to start with that, and then go to the commodity standard specific for your equipment or industry sector. So start with 652 and then move to 664 to determine, well, what would be different for my cabinet production facility. And then whenever there are differences between 652 and your commodity standard, NFPA does allow you as the user to choose which standard you're going to follow. My recommendation is, if you're going to pick a direction, have that documented. I go by OSHA's understanding that if it's not written down, it never happened. So documentation is going to be key, is just to say, well, we did this because this is what we came up with, and that's your prerogative. So I will say there is a long-term goal that's been discussed in the NFPA committees to merge all of these into one standard. It was kind of on hold for several years, then it made a few steps forward, and then it got hold, then a few steps forward, then COVID happened. So don't hold your breath for that, but that is the plan. So some of the major requirements of the NFPA standards is establishing facility layouts and building requirements for fire protection. They require facilities to obtain combustion properties, so to know if your material is combustible or not. Conducting the DHA, as we discussed, having the management systems up there to meet these standards and be compliant with those standards. And then the standards do have prescriptive requirements for equipment, which I'll go over. So prescriptive requirements, prescriptive requirements in the standard will tell you, you have a bucket elevator, it needs to be protected according to these notations. The protection needs to meet these requirements. It kind of prescribes you, it tells you what to do, how to do it, when to do it. But obviously within your DHA and management practices, you can kind of make your own facility-specific, company-specific version of that, as long as it is at least as safe as what's described in the standard. So some of those prescriptive requirements include explosion protection and isolation. Explosion protection and isolation, minimizing ignition sources. A lot of them go into detail about housekeeping. Some too much detail, some not enough. It's kind of the fun parts about safety standards. And then, of course, inspections and maintenance requirements. I will say kind of the bare minimum of inspection and maintenance is whatever the manufacturer recommends. So I'm about to go into some DHA, but I'll explain about a DHA team is, as you can see, there's a lot of prescriptive requirements in the standard. So having someone who knows the standards pretty well and the OSHA regulations pretty well, they should be going hand in hand. I'm working with a multi-facility grain company, and they have an environmental department, a safety department, a maintenance department, and then there's the actual operators at the facility. So when I come in for a DHA and I see, well, engineering put this in, safety didn't know about it, and the operators know they have to do it but don't know why, well, you kind of want everyone talking, because you need these prescriptive and administrative requirements to be met, the controls to be satisfied, and I think I have a little bit more of an example of that. You'll see these safeguards again. Some of the prescriptive requirements include explosion relief panels, protection systems, which you see an example as a suppression system, and then fast-acting valves is kind of a mechanical hard stop for any deflagration. I'll go more into these later. So that was kind of my intro to combustible dust part. I'm going to explain more of the what, the why, the how of a dust hazard analysis or DHA. I do these a lot. If you do have questions, I do have articles and white papers posted on our website. Please, I try to answer as many questions as I can in my writings, but please feel free and ask questions during this time. This can be a lot if you've never kind of been accustomed to it. So a DHA, a dust hazard analysis, here at CTI, we use a lot of acronyms. So DHA, the DHA's main requirement is to determine the presence and extent of hazards for a specific process. So you can do a DHA of your whole facility, that's kind of the point, but your DHA is looking at your specific process, specific equipment with the specific material you have, with specific safeguards you use. And then, I keep using bucket elevators. That's just the article I'm currently writing about. But if you have one bucket elevator at one of your facilities that's outside, and another facility has a bucket elevator inside, you can have this. It can be the exact same process with the exact same material, but inside versus outside, you're going to have a much different severity if both of those blow. If it blows outside, you have one thing, but if it blows inside, it's a little bit bigger of an issue. So with those standards I described, 652 standards of fundamentals of combustible dust has specific requirements. So like I said, it does require a DHA be completed for all processes by September 7th, 2020. I will say, I don't think they wrote that knowing that COVID was going to happen. But since it did, that was still the deadline. Those of you, I get asked this a lot too, is, well, what's OSHA going to do about that deadline? And that's a tough question. I think depending on where you are, it's going to depend on who shows up from OSHA. If you have a state OSHA program, I've dealt with them. They tend to be a little bit more in tune with the NFPA standard versus the federal guys. So that was the deadline. I'm assuming that they're going to give some leeway, at least towards the end of the year. With that, I have seen OSHA show up, give someone does not have a DHA done, and OSHA will say, okay, I'm going to come back in 3 months. I'm going to look at your DHA then. So I have been seeing them give some leeway. I've also seen them give citations. So those of you that deal in feed and food and agricultural products, January 1st, 2022 is your deadline. So this is for all current processes and equipment. For new processes or processors undergoing modification, pretty extensive maintenance or replacement or refurbishment, the DHA needs to be done before startup. So I would include that in your timeline for that project, for that capital, for that equipment installation. A DHA must be performed by a qualified person. I'll define that in the next slide. And then the big thing with the standard is once you do a DHA, it's not a one and done. It's not just something to check off your to-do list. It does require that a DHA be revalidated or reviewed and updated every 5 years. I personally like that in that if I give recommendations to a facility based on the hazards I witnessed, I would like to come back in 5 years and say, okay, you've completed these few things. This is in your capital, project calendar. You've done this. You've come up with action plans. It's not that everything always has to be done that 5 years. I mean, it's preferred, but as long as you're making positive headway, you're moving in the right direction, you're more aware, you're kind of using the recommendations provided in your next steps forward, then it's positive, and it's kind of a good grade after that 5 years. So what is a DHA? A DHA is a systematic review of your process. It would look at all areas and equipment that handle, generate, or otherwise use combustible material. It is meant to identify where fires and explosions can occur, identify the potential causes, sources, and consequences of an event happening, and then to determine if your existing or proposed safeguards are sufficient. You hear things like proposed or to be installed equipment. So for instance, at CTI, we can do a DHA at multiple stages in the equipment timeline. Obviously, we can come in, look at what you have currently and how it's operating and what your PM schedules and housekeeping frequencies are, and that satisfies the DHA. But then we can do what we call a desktop DHA. That is in the design process. So what we would do is we call it desktop because we don't have to be on site for it, but we would get the engineering drawings of the equipment and processes, layout maps, process, equipment, and material information like SDSs or lab data, and we can conduct the DHA with what is proposed to be in place. Those work. Obviously, a DHA needs to be updated depending on what's actually happening on site. I wish I could say that all facilities were built like their engineering drawings, but it doesn't always happen. So as I mentioned, NFPA 652 states that a DHA will be performed by a qualified person. That is what it says. So if you go to the definition sections of 652, it defines a qualified person as a person who, by possession of a recognized degree, certificate, professional standing, or skill, and who by knowledge, training, and experience has demonstrated the ability to deal with problems related to the subject matter, the work, or the project. So with that, I would say I like DHA teams. If you're going to do it in-house, you can obviously hire a third party like myself or CTI, where we have professional engineers on staff, safety personnel on staff. All of us, we have too many years dealing with regulations and hazards and identification. But if it's going to be done like on site, a DHA team can work pretty well. For stuff like that, I would recommend someone who's knowledgeable of the standards and regulations, someone who's knowledgeable about maintenance, so maintenance personnel, maybe engineering, and then definitely getting the operators involved because they're going to be answering a lot of questions of what actually happens. So in this picture, you just see an example of a facility layout drawing that I've done. It's color coded by hazard rating, basically. So areas where minimal dust accumulation does and can occur, moderate, high dust accumulation. We do a lot of maps based on specific rating. So you'll hear things like a Class 2 Division 2 area in which that there could be a potential dust cloud due to malfunction, or the inside of a silo is a Class 2 Division 1 location because there's a dust cloud during normal operation. So the facility layout is part of the standard requirements and can kind of help, especially if you're installing equipment, of maybe where you can and maybe you shouldn't install equipment. So how to do a DHA, you ask. So there's about 7 steps that I use to do a DHA. I'll go over them one by one. They're here. Give you a second to screenshot if you need it. So excuse me, the first step, evaluating material properties. So you need to know, well, what do I include in my DHA? Like I said, you can use every inch of your process and equipment, but are you going to want to put in, suppression systems and increased dust collection if you're moving salt around? No, salt's not a combustible dust. So you don't need, so knowing which materials that you handle and generate or otherwise use is pretty important. You can do that a few ways. You can, like I said, just assume everything's combustible and your DHAs can be really long, expensive, and take up a lot of resources. But first step, I would review the SDSs or safety data sheets of your materials. A lot of the ones that have hopefully been updated after GHS system came out should say if it's a combustible particulate or not. They don't always say that, so check the SDS first. If it says combustible, great, easy. You can include that in your DHA. If it doesn't, but you're skeptical, you can review textbooks, online databases, and the NFPA standards themselves have a great list of materials that are combustible. So if you look through 652, there's pages and pages of tables that show, well, this grain dust is combustible and it has an explosibility value of this, and it'll tell you, depending on what it is, how combustible is it. There are some online databases and textbooks that we use for those that are not in the regulation, excuse me, the standard. And then of course, if you, for instance, make pesticide powder, your material may not be in there because you make it. So it's your SDS. So if you just don't know, and you have there's no real way for you to just read to determine it, you can conduct laboratory testing. I will say for laboratory testing, for those of you that might have reached out to other people to do DHAs, I just find this a lot. I would not say you have to do laboratory testing on every single powder at your facility. Some people might disagree with me, but if you do that, it is very expensive. If you have 50 powders that you deal with, to get 50 explosibility tests at $1,500 a piece. So if you're going to do laboratory testing, we typically do it in conjunction with the DHA, because there might be areas, combustible or not, even if it is combustible dust, you have safeguards or housekeeping's appropriate enough, or what have you, that what you have is good. So you don't need to get the dust tested because there's no potential hazards that's going to come out of it. But if you do go forward with the dust testing, or you get a DHA that recommends, hey, test this dust to know how explosive, does it, meet the minimum ignition energy requirements of a bucket elevator, for instance, do you need to add grounding straps? There's a few tests to do. I would always first do what's called a go, no-go screening. So that will tell you it's the on the cheaper end of the test. It's still about $300 to $500 depending on the lab, but it'll tell you if your material is a go and combustible and combusted in their chamber, or a no-go and not combustible. So what the lab that we work with, we would do a go, no-go first, like for every dust, and then if it comes back as combustible, it automatically goes forward to do the KST and PMAX test. So KST is the deflagration index, or how explosive is your dust. So something with a KST of 12 is technically a combustible dust because it has a KST value, but that is very low versus certain flowers are 250. There's a huge difference. The PMAX is the maximum pressure from a concentrated deflagration. So those are kind of the two that get tested together after your go, no go of saying, yes, this is combustible, and how combustible is it? And then for further testing, you would do the MIE, or minimum ignition energy, which is if you have a big static problem in your equipment, or dust moving through a duct or conduit, you get static buildup. You need to know how much energy does it take for that dust to ignite. So that would be really big with your bonding, grounding, and electrical maintenance. And then the minimum explosive concentration, as we discussed earlier, of, well, how intense does that dust cloud have to be? One question I got recently was, well, if without getting all this tested and knowing how much dust is in the air, how do I know? And it's pretty interesting. It's basically if you can't see a light bulb 6 feet away, and that's the dust cloud in the air. Dust on a surface, which would be a minimum ignition temperature, like dust-coated motors, that's a little bit different. The standards do specify a very shallow depth allowed of dust on surfaces, but this is more in the air. And then P-red is the maximum pressure developed in the explosion, or excuse me, in the enclosure during venting. The KST and Pmax is typically what you would do. The other values get tested. You would need those for sizing of deflagration relief or protection systems. Yeah, and then with this, if any of you are in timber processing or wood pellets or anything like that, we all know that sawdust is a combustible dust and flammable, but for those of you in wood, know that if you get green sawdust that has a 30 to 40% moisture, well, that's not really a combustible dust problem. However, I have done a lot of timber facilities, and I live in Georgia. So if you have that dust, that 40% moisture that sits on your, overhang for 3-4 days in Georgia summer, well, that's going to drop down to about 5%, 4% pretty quickly. In fact, OSHA did show up at one of my sawmill clients. I did some testing of their dust. It actually showed that lack of housekeeping was the concern. And their green sawdust did dry within 3 days. So that can be a percent moisture test, which is a few bucks at a lab, or you can do it yourself if you have the equipment. So just things to keep in mind of why I keep mentioning housekeeping and different dust types and testing. So after you've figured out, well, which material is combustible that I need in my DHA, you now need to look at which equipment to include. So you want to itemize your equipment. Some of them can be paired together, some not. It's all going to depend on the resources that you want to use in your facility. But things like bins, tanks, silos, hammer mills, and grinders are pretty big because they can create their own ignition sources, just like dryers and ovens. Dust collectors are very important. It's kind of the perfect storm of a potential deflagration and explosion hazard. Conveyors, screw augers, bucket elevators. And in fact, as I mentioned earlier, that Imperial Sugar explosion that happened years ago, it was a lack of housekeeping plus a bearing issue in a covered drag conveyor. So it was kind of a perfect storm of multiple things going wrong. And then of course the sifters, screeners, and classifiers that really sift out that fine material, because you're going to have a lot of fine material. Just like in a dust collector, when your air pulses on the filters, you get a concentrated dust clouds of fine material. Once you've gotten your equipment, you now need to identify the fire and explosion hazards. So you know the equipment, you go through that equipment and areas, I repeat, and areas, and you look at what can burn, how it can burn, how can a dust cloud exist in this equipment or area during normal operation, or would it only happen during an upset condition? Are you looking at a bulk bag unloading station with that maybe even has dust collection on it? You're like, well, that's a closed system pretty much, so there's no issue. But there is an issue around that station, in that if that bulk bag drops off the hoist, well, you can get a disbursement of whatever of powder in the air. So that would be an upset condition. Identifying where your dust accumulation is likely, like I said, overhead areas. Please look above your drop ceilings. It's kind of, if I show up on site, just know I will look at above your drop ceilings. And then obviously those areas that are just tough to get to and hidden. With that, you want to identify your ignition sources, whether it be electrical sparks, static electricity is kind of that hidden gem, hot work, process heat, friction. Friction is something I'm dealing with now at another facility where they had a bearing overheat due to a bird that was making a nest on top of the bearing and dropped material onto the rotating shaft, which caused friction, which overheated the shaft and got into the bucket elevator. It was a whole big thing. But so identifying those, the open flames, dust blanketed motors, things like that, and that's going to really show you, well, where can the hazards occur? And then once you know what equipment and kind of how an incident can occur, you want to look at it from a what if. Well, what if something goes on? What if there's a deflagration? How can it propagate to upstream equipment? Can a chipped hammer be a burnt ember going into your dust collector? What safeguards do you have in place? Engineering controls, administrative controls. What type of equipment do you have? Is it near an occupied location? What are the potential chain reaction events of something happen, a secondary explosion? So you really want to look at that. Well, what if this happens? That's going to help you kind of figure out your severity of an incident occurring. So I just wanted to show some examples of safeguards. You've heard me talk about explosion relief vents. That's these. It basically creates a weak point in your equipment that if there is a deflagration or explosion, it's going to rupture those panels or blow them off, and it's going to be directed in that location. I am currently writing a recommendation to a facility that has those onto the platforms for the ladder up the bucket elevator. So it's a whole thing about maybe potentially looking at moving this, including training, signs, things like that. You do have deflagration suppression or chemical relief cannons. I know FIKE does a lot, IEP does a lot. Those are going to basically be like a fire extinguisher inside your equipment or conveyance line. It's going to detect that spark or that hot piece and or that overpressure, and it's going to flood the system. Spark detection and suppression work pretty well in the metal and timber industries. It basically detects a spark, not particularly a hot ember, but a spark, and floods the system typically as like a water deluge. Things like mechanical gates, an abort gate, which would, what happens if an explosion occurs and there's a pressure wave propagating through a conveyance line, it's going to mechanically close that gate and be directed up the spout. Similar to a backblast damper, is it's going to close that gate and stop it like a wall, and you'll lose that safeguard, but you'll keep all the equipment down upstream and downstream. Obviously, I've talked about housekeeping plenty. I look at schedules, how housekeeping is done, where, by who. I talk to them. So once you've got all that, you have identified where your risks are. You now need to evaluate the risk. At CTI, our DHA system, we are engineers, so we like numbers. So we do a quantitative approach based on likelihood of hazardous atmosphere, likelihood of ignition, and then the severity of something going on, of that incident occurring. So you plug your things into your risk matrix that you and your team decide, and you can rate your harm based on what the risk matrix will tell you, and that'll also help prioritize which items should be addressed first, how much resources, how much capital to utilize. So once you get your results that I just explained, or you hire us and you get this wonderful comprehensive report, you want to look at those results and recommendations, if it's from someone like us, and it should identify where your areas or equipment that are either unacceptable levels of risk or could use more safeguards in place to minimize that risk. The most important part is once you get the results and identified risk from the DHA, you want to take a step back, have a discussion with your DHA team, maybe bring in upper management and come up with a reprioritized list, an action plan, and determine what resources and capital need to be available just to minimize the potential hazards and risks in place, or meet whatever citation or your insurance company wants this done, and you need to satisfy their potential level of risk. So maybe you bring in, after you have this final meeting, maybe you would bring in one of those, your insurance representative, to go over it with you. I will say your insurance representative, especially if they're the ones having you do this, they could be hopefully a good resource for you on what is needed for your facility. So that's my combustible dust and DHA in a nutshell. This is my information. If anybody, I have not seen any questions posted on the chat, but I have received questions from another source. So if anyone has questions, please post now or raise your hand, or Howard.
And Adam, this is Blair
Yes.
again. I did see a question pop up.
Oh.
It's a question from Luke Mace. He says he may have missed this, but how are the vents and discharge ducts sized to assure they're the right size for a certain dust collector? Okay,
Luke, very good question. So vents and discharge. So you're talking about like the deflagration relief stuff. So that's going to be through the dust testing I told you about, because the P-red is on your equipment. That's the value for your equipment to rupture. But you would get your KST, PMAX, MEC, all those tests. That would help. That's what's needed for the sizing. And then you would call whoever is installing and building that equipment. They're the ones that would be sizing it for you based on the volume of your dust collector, your airflow, your dust to air ratio, and those values. So if you want to use a Fike flameless vent, I'm not promoting any company, it's just what comes to my head. If you want to use a Fike flameless vent, they're going to size that vent based on all those values, as well as the dust collector, as well as the area around it. So you're going to utilize your dust testing, as well as the equipment manufacturer or fabricator that's putting it, that they're the ones that are going to size it for you. You're welcome.
Thank you, Adam.
Yes.
And Luke says thank you as well. As
great.
we give folks another couple minutes to type questions into that chat box, let me cover just a few housekeeping items, if I might. First of all, Adam, thank you so much. That was great, detailed information. I personally really like the systemic process-based approach you take on this topic. I learned a lot from listening.
Great.
Speaking about CHMM, we would love to have all the participants on this webinar join the group for future webinars and hopefully in-person events before too much longer. If you visit cochmm.org, our website, you'll see on the main page there is a link over to the right side that says subscribe to our mailing list. That will enable you to get all of our constant contact updates and be up to date about future networking opportunities. Also, if you have entered your email address as a part of this webinar, we will be sending out a PDF version of Adam's slides within the next day or so. If you didn't enter your email address when you first logged on to the webinar, it's not too late. If you'll left click on your name under the People tab, you will see the second option down says Edit Name and Email. If you click on that and edit the email field, then we'll have your email address and we will be able to share slides with you after the webinar. Anyone have any last questions? I don't see anything that's been typed into the box. Adam, did you have any other questions you wanted to share? We have 2 minutes left.
I have one good question that I got asked, and I just want to share with everyone because I see this in a lot of facilities. I was asked when vacuum suctioning powders into a vessel. So I'm not talking about a shop vac. I'm talking about pretty much like a central vac. If the vacuum wand has a continuity cable that extends around the entire hose and connects to the reactor vessel, is that effective grounding? Because they use plastic vinyl hoses that are not static dissipating. I see this all the time, especially with truck unloading into a silo. And that's where dust testing is going to come into play here. Is if powders have a low MIE, so the low ignition energy, you definitely want to use static dissipating hoses because the static charge can accumulate on the hose itself. So what I described is okay for some dust, but not for others. And when in doubt, use static dissipative hoses. Those are the ones with the metal coils going all the way through. And what I check when I'm on site is that flex line or whatever it is through the hose, that metal coil is bonded on both sides. Hopefully, a DHA will shine light if you have issues in a bonding grounding PM program, but that's just, besides housekeeping, that is one of the bigger issues that I personally see on site. Just wanted to share that. I thought it was a good question. And then if for all of you that are out there, I obviously don't live in Ohio. I am from Georgia, but we do a lot of work, actually pretty extensive amount of work in the Ohio region. We do have a few partnerships up there, so love your region. Just putting that out there for everyone.
Well, thank you, Adam, for presenting today. It was very informative, and thanks to all our participants for joining in. Adam's contact information will be on the PDF of the slides you receive, and we hope to see you at a future meeting of CHMM. Thank you all, and have a great day.
Thank you, everybody.